student. Today we will going to learn the topic relation and poset. Before we introduce the concept of poset, you have to understand what is the meaning of relation, what represent relation in the set theory. It's your module 1 number theory, module 1 PCCCS 404 paper code topic. So we start the topic relation. The first we observe the definition which you can see in your screen. Definition of relation. A binary relation or simply a relation R, the relation is defined by R, from a set A into a set B is a subset of A cross B. Again, you repeat the definition. A binary relation or simply a relation R from a set A into a set B is a subset of A cross B. So, when we can capture this particular topic, in that case, you should remember what is the definition of subset. A set A is said to be a subset of the set B if for all x belongs to A implies x belongs to B. That means every element of the set A should be an element of a set B. Then we say that A is a subset of B. Here I use the Cartesian product A cross B. What is the meaning of the Cartesian product of two sets? It's a order pair. The first element comes from the first set, preset, and the second element comes from the second set. If we recognize or remember the concept of plotting a point in the two-dimensional coordinate system, say we take an example 2, 3. It's an order pair. That means 2 represent its coordinate of x and 3 represent its coordinate of y. So when we mark a point 2, 3, it's represent the x coordinate is 2 and the y coordinate is 3. And why we use the order pair? Because order pair is most important. If we write a point 2, 3 and another one who write the point 3, 2, you can easily recognize that they are not the same point, because 3, 2 its x coordinate is 3, y coordinate is 2. So order pair is very important. So the binary relation is a subset of the Cartesian product of two sets. What is Cartesian product? Cartesian product is the order pair. First set comes from the first position comes from the first set and the second position comes from the second set. So if we take this example to understand what is the meaning of the Cartesian product A cross B, then we go to the concept of relation. A is a set, B is another set. If we take the Cartesian product of A cross B, the element of the Cartesian product of A cross B should be 12. The question is why we say it's 12. The element should be 1, P, 1, Q, 1, R, 2, P, 2, Q, and 2, R. Similarly, 3, P, 3, Q, and 3, R. Similarly, 4, P, 4, Q, 4, R. That means for 1 we get 3 element, for 2 we get another 3 element, for 3 another 3 element, and 4 another 3 elements. So the total number of elements should be 3 into 4, 12. That is the Cartesian products. And what represent relation? Relation is the Cartesian product of two set A cross. Cartesian product of any two set. Binary relation or simply a relation. So we discuss the concept of relation in this particular example. If we consider R is an relation of the Cartesian product of two set A cross B. If we consider the member of R is 1 comma q, 2 comma q, 3 comma q and 4 comma p. So that should be the element of the Cartesian product A cross B, because 1p should occur, 1q should occur, 2q occur, 3q is also occur and 4p is also occur. So it's a subset of the Cartesian product of two sets. So we can say that R is a relation, R is a subset of A cross B. So R is a relation from A into B. Here you should observe a very important notice. Here we represent the notice. You should recognize this notice. Notice. What is the notice? Notice is 1 is R related to Q, because 1 comma Q is a member of R, capital R. So 1 is R related. We just pronounce that 1 is R related to Q. But it's very important. 3 comma P is not a member of the set capital R. So 3 is not R related. So here we just strike out the R. Let's represent 3 is not R related to P. So let's say another procedure for approaching the relation, that is known as the arrow diagram. It's easy because if you can visualize any concept or take a drawing of any concept, in that case you can easily understand the concept. So here we can represent a diagramical representation of relation. This arrow diagram, it's mentioned here, if a set A and B are finite, then we can draw a visual diagram describing the relation R from A to B. It's very important. From A to B. This line is very important. This line is very important. From A to B. I'm not mentioning from B to A. I'm here mentioning from A to B. If we consider the relation R from A to B. So give an example for the drawing. You can easily recognize the concept. Here it's an example. A is a set. Here we consider the set A is 2, 3, 5 and B is another set which is 7, 10, 12. We defined a relation R. We just defined a relation R from A to B as follows. What's the relation defined? For all A belongs to capital A and B belongs to B, the relation is defined is that A or B if and only if A is divides B, or B is A is a divisor of B. So the member should be 2 divides 10, 2 divides 12, 2 divides 30. So 2, 10, 2, 12, 2, 13 should be the member of the relation. 3 divides 3 does not divide 7, so 3, 7 should not be the member. 3 does not divide 10, so 3, 10 should not be the member. 3 divides 12, so 3, 12 should be a member. 3 divides 30, so 3, 30 should be a member. Similarly for the case 5, 5 doesn't divide 7, so 5, 7 should not be the member of R. 5 divides 10, so 5, 10 should be a member of this relation. And 5 divides 30, so 5, 30 should be a member of this relation. So this one is the subset of the Cartesian product of this set. Let's see your question. How many number of element occur in A cross B? The element number of element occur in A cross B should be, here is the number is 3. The set A contain 3 elements, set B contain 1, 2, 3, 4, 5 elements. Therefore A cross B should consist exactly 3 into 5, that is 15, but 3 into 5, 15 number of elements. Out of this 15 element, we just consider 1, 2, 3, 4, 5, 6, 7 element only. So R should be a subset of the Cartesian product of these two set, and R is defined by, according to the definition, R is defined by if and only if A is divisible, A is divides B, or A is a divisor of B. So if we make a diagramical representation, so it's the diagramical representation of the previous example. 2 divides 10, so we just make a arrow from 2 to 10. 2 divides 12, so we just make a arrow from 2 to 12. Here it's another 2 is divides 30, so we just give a arrow from 2 to 30. Similarly 3 divides 12, so we just make a arrow from 3 to 12. 3 divides 30, so we just make a arrow from 3 to 30. 5 divides 10, so we just make a arrow from 5 to 10, and 5 divides 30, so we just make a arrow from 5 to 30. That is the diagramical representation of a relation. But this diagramical representation you can only do for a finite case. If the number is infinite, if the set A has infinite number of element and B has infinite number of element, in that case you cannot draw this diagram. Next we take an example, this one, for your better understanding. If we consider the same set, let A be a set, R be a relation defined by the following set. That means A is a set, we just take a Cartesian product of A cross A, then how many number of element in A cross A? That should be 4 into 4, 16, because A has 4 element, the next A has also 4 element, therefore the number of element in A cross A should be 4 into 4, 16. So here we consider a subset of the Cartesian product of set A cross A, A, B, B, C, B, D, and C. 1, 2, 3, 4, 5, 6, 7 elements. Just we consider these 7 elements. Then how can I draw this diagram? Here it's a complete diagram, but when you start your drawing, how can I draw the graph? First we make a point, this 4 point A, B, C and D, okay, according to the set A. First we observe that it has a self loop or not. How can I say it has a self loop? If A comma A, that means the point repeated twice, A comma A itself is a member of the relation, that means A to A must have a relation, so A to A have a self loop. A to B, here it's arrow from A to B, next one is B to B, B to B, next one is B to C, B to C, B to A, B to A, and B to D, this one is B to D, and C comma D, that is C to D. That should be your arrow diagram. Okay, then if a arrow diagram is given, how can I say that the set consists A, B, C, D, D itself? How can I say? If every vertex has a self loop, then we can say that the relation in that relation A, B, C, D should occur. But here in this diagram, according to the reverse, if we consider the reverse concept, and the diagram is given, how can I write this relation? You can easily write this relation because A to A has a arrow, so you have to make A comma A. B to B has an arrow, so you write element B comma B. A to B has an arrow, so A comma B should be element. B to A is an arrow, so B comma A should be element. B to C should be, B comma C should be element. B comma D should be element, and C comma D should be a element. So that is the first lecture. Next we move the different relation, the difference naming of the relation, like reflexive, symmetric and transitive, and what is the definition of the reflexive, symmetric and transitive, and how can I recognize from the arrow diagram the graph the relation should be reflexive, symmetric or transitive or anti-symmetric. So wait for the next lecture. Feel free to contact with me. My mobile number 97488797999. Another number is 9433505994. Again, I repeat, my first number 97488797999. it's also my WhatsApp number. Thank you for learning.